Minimum?
the minimal. And they say, they give it the name A, and they give this the name B, but it's simply the maximal. So we're just describing what the uniform distribution looks like. If we say it's a normal distribution, what are the two characteristics that we put here? No. If it's uniformed, it looks something like this. And what do we use to calculate the z-score?
Mean and the standard deviation.
And that's what goes there. If it's a normal table, this is always 0 and 1, depending on what we sort of look at. So when we start looking at those are just ways that we describe the distribution that we're looking at and the main characteristics of it. So it's just a way of describing it. And that when you look at the book and it sort of tells you that what you're looking at. What was the biggest one that gave you guys fits on the web assign?
Everything.
Everything. Percentiles. Percentiles are, I hope. So if we look at the one, okay, where'd it go?
I was having problems with number 7 after we do the percentile thing.
Is this one
Okay. For percentiles, if you get it close enough, basically, we were looking at the one, so if we were sort of looking at, say, the uniform distribution where it was 1 and 53. Okay? Basically, if I want like the 80th percentile, basically I just want to know 80% of that. I just want to know about 80%. So there's my 1, 2, 53. I just want about 80% of this box. And the closest way to get that is to sit there and say, well, I'm going to just take that. So if I want to know how far it is from 1 to 53, how far is that? How far is it from 1 to 53? How many steps? No. It's actually 54.
Let's count to 1.
Huh?
You gotta count 1.
You gotta count to 1. So it's basically 54 steps. So if I look at this, this is 54 steps. And if I take that and multiply it by 80%, what do you get? You get about 43.2. So that means the value 43.2 is roughly 80% of the data is before it and 20% of the data is after it.
So since that example was in weeks, it will be 53.2 weeks. 42.
Yeah, roughly. Now, a lot of times when you come up, you might remember, I've talked about it a couple of times. If you're if you come up with 43.4 and it's 43.6, don't overly fret about that. What would be 2/10 of a week?
On what?
What would be 2/10 if you came up with 43.4 and you look at X at the book, and they said the answer should be 43.6. You're off by 2/10. What's 2/10 of a week? It ain't a heck of a lot. I would not overly fret about being off by 2/10 when it comes to calculating percentiles. Let me see, 2/10 of a week. Let me see, 7 days times, 7 days times 24 hours is 16 times 0.2. That's like not much. Okay? I would not overly fret about that. You're not overly, it's not going to be that critical. I'm not going to be that critical about that. So when it comes to percentile, just remember, that's about 80 percentile. Now when they talked about quartiles should be a little bit easier. Because quartiles means you're dividing your data into how many? 4. So it's going to be a little bit about the same. So you just divide things by 4. Now the one that I know Bronson and Abby both came to me with was the one that was something like this. It said the probability that you were, what was it? 13 is less than X. What does that straight line mean? Given that that X was less than 24. Well, remember, that's a given probability. Probability of A given B is equal to what?
B.
The probability of A and B divided by the probability of B. Now, when we start to look at that, and we were looking at different aspects of this, so if I'm looking at this, 1 and 53, what's my probability over here?
1/52.
1 over 52. What is my event A? Now my event A here is that X is greater than 13. Or 13 is less than X. They both say the same thing, right? My event B is that X is less than 24. No, that's what it says right there. I wrote this one the opposite way. Okay, that's just, I wrote it the opposite way. Don't overly fret about that, because things are going to happen that way. I am older than you. You are younger than me. Did I say anything different? No. It just depends on whether I start with the 13 or the X. 13 is less than X, or X is greater than 13 says the same thing. If I was up here reading it out of a book, you wouldn't know whether I was actually looking at, if I said X is greater than 13, I could very well be looking at this and reading this. And if I'm reading the book, you don't know which way I actually see it, because I have a problem with directionality. Okay? I am as likely to read this as X is greater than 13 as I am to say 13 is less than X, because I don't always read from right to left. I see this and I as easily read left to right as I do right to left. My eyes just see it and I go ahead and say it. So you don't, if I'm reading it, you don't know whether I'm looking at this or this. I could be looking at this as well as this and say the same thing. Because I just, yeah, I'm not good at directions. So, all I gotta do is think about my probabilities of being this. So, my B and A, or A and B, depending on how I want to say it, means that my X is between 24 and 13. See, I'm just going back and looking at this, which we learned in the last couple of chapters, right? Probability of A given B is probability of A and B divided by the probability of B. And then I just defined it. The probability of A is being greater than 13. The probability of B is being less than 24 because that's where they're at. And then the probability of A and B, and see, what did I write? I wrote B and A, but I'm saying A and B. Because I screwed up when I wrote it and I'm not going to fix it. Okay? Is X is between 13 and 24. I can calculate those probabilities fairly easy. The probability of X being greater than 13 is 1 over 52 times what? 13 minus being greater than 13 would be 53 minus 13. I really don't need that in this problem. Don't need probability of A, do I? I need the probability of A and B and the probability of B. The probability, I can't write with my mouse very well. There it goes. So those are the three probabilities. I really don't need this one. I just did them all. So if I want to go back up here, the probability of A given B, so the probability of A and B is what? 24 minus 13 is 11. So this becomes 11 over 52. And B, the probability between 13 and 24 would, whoops, that's the 11. Whoa. What was that, John?
I'm still trying to figure out B. How is
Because it was part of the given problem.
24 minus, in your equation for B, probability X is less than 24. you take 1/52 and then you multiply that by 23. Is that right?
For which one?
Probability of
The second.
x is less than 24.
Okay, so this is 1 over, or 23 over 52, yes.
Okay. I'm trying to figure out why that's 23.
What's my lowest, if I look at this,
Oh, okay.
here's 24, right?
Yep.
I want this area right here. What am I between?
Gotcha.
I gotta look at the picture. Because my minimum was 1. I'm going back to my picture. Had I gone all the way, had it been all the way to 0, then I wouldn't have had to do that minus 1. But my 1 was my low point,
Got it.
my minimum. I had to go back to what it was saying in my picture. I can't do these accurately without a picture. Every time I try to do these just straight without pictures, I get lost real easy. And then see, so that's that part, and then see the next part is I want to be between 13 and 24. So that would be my 9 out of 52. And then when I go back up here, that gives me 23 out of 52 divided by 11 out of 52. How do I divide fractions? I multiply by the reciprocal. So when I go and do my arithmetic, I get 23 over 52 divided by 11 over 52, which then becomes 23 over 52 times 52 over 11, and that's going to be incorrect. Because I wrote them backwards.
Yeah.
This is my probability of A and B is 9 over 52. How did I know I had to be incorrect? Why did I know as soon as I wrote it I had to have screwed up?
Probability would be greater than 1.
Because probabilities are always between 0 and 1. And I would have got 23 over 11, which would have been 2 something, right? So I knew I had to screw up. And I screwed up because I wrote the probabilities in the wrong place. See, everybody screws up. Because this is my probability of A and B. See, there's my probability of A and B is between. So that is my numerator. Was that 9 or 11? See, I can't subtract.
Okay.
And then the other one, probability of B, probability of B is less than 24. So here's my probability of B. Circle that in green. So a lot of times it's a matter of writing things in the right place. So B is 23. And then when I do the arithmetic, I I get 11 over 52 divided by 23 over 52, which gives me 11 over 52 times 52 over 23. The 52s cancel out, so I get 11 over 23.
Oh, you have to.
But I gotta keep this in mind, it's a given probability, and what was my form for a given probability that we learned was the probability of A given B is the probability of A and B divided by the probability of B, and then I have to go down and think about what my probabilities are. The probability of A is not really necessary in this problem. I need the probability of B and I need the probability of A and B. I really don't need the probability of A. I wrote them all down just because those were the three pieces that I have to work with. That to me was probably one of the trickier ones on there.
I got it.
Okay. So we basically have talked about everything in chapter 5 and chapter 6 that we have to be able to work with.
Can you do number 7?
Huh?
Can you do number 7?
Can we do number 7, hopefully?
I almost figured that out, but I couldn't get
The SkyTrain from the terminal to the rental car and long-term parking center is supposed to be every 8 minutes. The waiting times for the train are known to follow a uniform distribution. Okay, so if I'm going to do that, what are my uniform distributions? My uniform distribution is something like this. So we have our X given, it's a uniform distribution. What's our minimum?
0.
0. I can walk up there right as the train's getting there and I don't have to wait at all. What's the maximum? 8.
8? Oh.
In my case, and some of you guys have different numbers, I'm sure. But in mine, see, that's what it said there. It said is every
8 minutes.
8 minutes.
Okay.
Okay? How do you calculate the mean?
You add the 2 and divide by 2.
You take the minimum plus the maximum and divide by 2, which in this case would be 0 plus 8 divided by 2, which is 4. What is the probability of waiting more than 6 minutes given a person has waited more than 4 minutes? So this is, what is the probability of waiting, what was that? Waiting more than what?
6 minutes, given you waited 4.
Given 6 minutes, given that you waited 4. Oops.
More than.
More than 4. Okay.
More than.
So the time that you waited more than 4 minutes, given that you've already waited 4 minutes. So again, this is a given probability.
Oh my goodness. Oh.
So again, if I'm going over and looking at this, the probability of A given B is the probability of what? Is the probability of A and B divided by the probability of B. Okay, what's my probability of B? Oh, crap, what did I just do? So what's the probability of B in this problem?
The W is greater than 4.
Weighting greater than 4. So the probability of B is the probability of waiting more than 4 minutes, which would be, now I have to go back to my uniform distribution. This is 0, this is 8. What's my probability?
I think she would say 6.
1/8. So my probability of B is, see if I go back to this, looking at this, it says, what is the probability of waiting more than 6 minutes given a person has already waited more than 4 minutes? So the waiting more than 4 minutes is my B. Okay? So my probability is 1/8. So the probability of waiting more than 4 minutes, whoops, where is it? Would be 1/8 times what? 8 minus 4. Which is what? 8 minus 4 is 4, so this would be 4/8 or 1/2. What is my probability of A and B? Well, the probability of A and B would be, if I waited more than 4 minutes and I've waited more than 6 minutes. So the probability of A and B.
Wait, so the 6 minutes is not the 8 minus 6. We don't do the same thing like how we did with B.
Would be, the probability of A and B would be 4 greater than W less than 6. A and B would be between 4 and 6.
What? I thought it was.
Yeah, right.
A and B would be between 4 and 6.
But I thought he waited more than 6 minutes.
What is the probability that he will wait more than 6 minutes if he's already waited more than 4 minutes? So the probability of being between 4 and 6 is the and, which would be 1/8 times 6 minus 4, which is 1. Is that right?
Yeah.
2/8 or 1/4. So my probability of A and B is 1/4. My probability of B is 1/2. If I do my arithmetic, 1/4 divided by 1/2 becomes 1/4 times 2/1, which is still 1/2, which happens to be the same as the probability of B. I just walked out the entire, I didn't take any shortcuts. But there's my, I have to define what is my A and what is my B. And they wrote it as a decimal, not as a fraction. So I have to be able to define what is my A. And see, I don't really need to know what my probability of A is. I could have calculated it. But I needed the probability of B and the probability of A and B. But it goes back to here. To do this, I have to be able to find these two pieces. So I had to define those. The probability of B was waiting more than 4 minutes. The probability of A and B is waiting somewhere between 4 and 6. Now, what I'm going to do next is I'm going to start introducing chapter 7. And chapter 7 talks about the central limit theorem. And the big part about chapter 7 is you got to get two things down very carefully. Is there a difference between these two?
Yes.
Yes. What does this mean? I want the standard deviation of the variable x. What does this mean?
Sample mean.
I want the standard deviation of the, what type of means?
Sample.
Sample means. Okay? So here's what we start to do in statistics. This is where we all start putting everything together. Most of the time we can't get this because there is no way to deal with the population. Because the